Hi everyone, welcome. Today we're going to be taking a look at an AI tool that is for HR professionals. And the purpose of the tool is to take a job description that you'd find for a position in a company, so things like you'd find posted on LinkedIn, and match that job description to the appropriate match within a compensation salary survey. This is a very common task among HR and compensation professionals. It's very tedious. It involves a lot of reading and toggling between a job description and a long list of survey jobs. So, given some of the advancements in language models over the past couple of years, we thought that it would be a natural fit to point some of those models at this problem. My name is Robert Kelly, and I built this tool with Jack Keeton. We built it together with input from Robin Parente. So let's jump in and show you how it works. Okay, so let's first take a look at the problem that we're trying to tackle a little more closely. So um, right now, a compensation or HR professional has a common task. This happens all throughout the year where they will receive a job description from like a hiring manager that describes a new role that they want. And the task for the comp or HR professional is to match that job description to the best, closest fitting job on a compensation survey. And the reason you do this is you want to see what the market salary information is for a given job. So when you have to publish a range, when you post a job publicly, you will be able to determine the appropriate market pay rates. So to accomplish this task, essentially the HR professional reads the job description and then opens a file, usually an Excel file, of a compensation survey. And compensation surveys are provided by third-party companies who collect a lot of data about various different jobs and then publish a survey with results. So on one of these surveys, there can easily be over 500, actually easily be thousands of jobs listed. And when you're trying to find the correct match for your new job, what people end up doing is reading the new job description and then kind of toggling over to this big Excel file with a bunch of descriptions, and you sort of read through those until you narrow it down into the best match, and then record your answer. But it's very tedious, and particularly if you have many jobs to match, this can take a huge amount of time, and then it also requires human judgment, and so you can get different answers depending on which human is doing this match. So it's a tedious process and a little bit error prone. So we'll go into the real demo to show the system in action in a second, but just wanted to review the workflow to kind of lay out what we're about to see. So this is essentially a job matching assistant, meaning the user is overseeing its work as it does the work. So this isn't something that runs completely autonomously. It helps the user do this task much more quickly and more accurately, but it does require user input. But we can break the workflow into really four steps. So the first step is you input into the system a sort of quote unquote raw job description. So this would be a job description that is like found on like LinkedIn or Indeed or any job posting site. And because people write these, they're always written very differently from company to company, and even different departments within a company. So we have to use as a first step a fine-tuned LLM to read the raw job description, so however that person wrote it, and extract in a structured way the responsibilities, experience, and skills that are required in the job, which are the fields and information that we care about in the rest of the system. So the first step is to take the unstructured, sort of raw job description and convert it to this structured output. Once we have the structured output, we can then feed that to step two. We use another LLM to read that structured JD, that structured information, and make predictions about the job family and job level. Once we have these, we then take those predictions and use an embedding model to probabilistically rank the top suggestions of survey families and survey levels that would match the predictions in step two, and then ask the human for the first time to weigh in. So we give the suggestions and we ask the human to confirm or pick from those suggestions which one is correct. And then at the end, we store all of those confirmations with the appropriate survey codes and titles into an Excel file and spit it out for the user to have to move forward. It's important to note that this system, unlike a lot of other LLMs, like with OpenAI or Anthropic or other big proprietary AI companies, this runs completely on a local computer. So there's no API that's needed. You could put your computer on airplane mode and the whole system would still work. Which also means that there's no fee every time you run it. You don't have to pay an API cost to run it. And importantly, for HR data, this also means that the data never leaves your local computer. So it's very private and does not expose either your job descriptions or the survey matches, which are also proprietary information. It stays completely on your hard drive. Okay, so now that we've covered that, let's start taking a look at the actual tool itself. Okay, so the first input is just a list of jobs. So I found these jobs on LinkedIn, and you just basically need some unique identifier. In this case, I used the LinkedIn URL, the description, which it says description cleaned in the Excel file, which just means I remove the HTML tags, and then the title of the job. So this is what we're about to input into step one of our workflow, which again is just going to convert all this very unstructured text that you see in the description column into responsibilities, experience, and skills. And we'll use a fine-tuned LLM to do that, which I should mention is all written in Python, and I can talk more about frameworks if anyone is interested. So here we'll launch the fine-tuned LLM, which is essentially just going to take as a prompt that unstructured job description that came from the Excel file we were looking at, and then kind of loop through each job asking for the LLM to extract the responsibilities and then the experience and then the skills. So you can see, again, this all runs completely locally. We could get into how to fine tune an LLM on a local machine if there's any interest for that. But assuming we've kind of already crossed that threshold, this is what it looks like in action. So this is real time up until about right now, where I'm speeding it up to 20x, and I won't make you all watch all the predictions, but this takes a few minutes to get through a list of, approximately like 15 job descriptions. So we'll go ahead and kind of fast forward to the end here. Okay, so now our program has finished converting and we see the output, which is another Excel file. And we just have columns for responsibilities, skills, and experience that have plucked that information out of the description. And this file right here will serve as the input to the next step in our workflow, which is step two, which is going to be interpreting this information and finding a survey match. Okay, so now we're ready to do the actual matching. And this happens within one program in several steps. So the first thing we need to do is pull our data in that we just prepared in the previous step and clean it up a little bit. The next step is the fuzzy matching section. And this essentially just looks for very easy matches. So specific titles that are very distinct and match almost one-to-one between the job description we're trying to match and the survey. So this can happen really quickly using fuzzy matching, and we just want to remove them to reduce the number of work jobs that we have to match right out the gate. So in this set, there were 5 of those, so we'll just kind of record them right off the bat as like those are obvious. After we've done that, we then proceed to the family predictions. So this is where we use a base LLM. So in this case, we're using Mistral 7B Instruct base model to just read our structured job description, so our responsibilities and experience and skills, and make a prediction for what family that sounds like. So it literally reads that information and then says, oh, this sounds like this job family, and then writes a brief description of what that job family would do. And the reason we do this is so we can take the many different lengths that we find of text in responsibilities and skills that are required, and kind of distill it down, compress it down into one more matchable piece of information. It's not going to be perfect, which is why we still need the user to validate as we go, but it gives us a really good starting point and does surprisingly well. All right, so now that we've gone through and made those predictions, we are ready to move on to the next step, where the user will now be pulled into the process. So we break this apart into 2 sections. So right now we're on the job family matching section. After we've done that, we'll do level. So what has happened here is we've used an embedding model, which is a way to find semantic similarity between 2 strings of text. So in this case, we're just going to loop through our 10 jobs that we need to match and try to find the best family. So in this case, we're looking at a customer success job, a senior manager job. The previous step, LLM, predicted a customer success management. That seems like a pretty good prediction based on the information below, which comes from the job description. So we display to the user responsibilities and skills listed in the job description for what's required. And then in the next section, we have some of our sort of AI output information. So the top list of 5 shows the most probable matches according to our embedding model of families that exist in our survey we're matching to. So these are what the AI thinks are the best matches in order of most likely. And then next we have our AI proposed family. So this is where we're asking the user directly, hey, the AI is proposing this customer support family. Below are the jobs in the survey that map to that family. Does this look right to you? And in this case, while customer support is somewhat close of a match, we actually do not have the correct suggestion here. So the user can put in no and cycle to the next family on the list. And this list is really useful because you can see the families that are coming up. If you're not sure about a match, you can kind of see if like there's another one in the queue that might be better because it's just cycling from the bottom to the top as a user would say, no, we don't have the right one. So this is an example of a somewhat tricky family to match for the embedding model. In some future version, we might be able to fine tune this embedding model to get a little better at this. But for now, we're going to have to cycle through a few no's until we find the family we're looking for, which is customer experience. So we see it now on the list. We know it's upcoming. That's the one that we like the most as this match. So we're just going to kind of cycle through telling it no on its suggestions until it suggests customer experience, which will be the next one. Here we go. And tell it, yes, you found the right one. And the AI will record that as the family match. So again, this is a little bit, some job families are a little bit harder just because the semantic meaning from like customer experience and customer support can seem very similar to an AI, but not exactly be. So this is where the users is very useful. But as we see some of the later jobs, it becomes much easier. So here's an example of our next job. It's a senior director of YouTube TV and uh, looks like a product manager. We can kind of browse through the responsibilities and just confirm some piece of information that, yeah, in fact, this does seem like a product manager. So the AI has predicted a pretty good family. And if we scroll down more toward the bottom here and kind of browse through some of the responsibilities and skills, we see some matches and the AI prediction here. The number one looks good, a product management family. So we'll just take its prediction as yes. And again, most of the time it's a little bit easier like this one versus our first example. Um, but this is, again, just where this is an assistant for user, not a fully autonomous system. Um, so we'll kind of cycle through some more in the background here, so you don't have to watch the full system, but you sort of start to get a flavor of how this interaction and what information is displayed for the user, and how the system records answers. So let's go ahead and kind of fast forward through some of this matching and get ready for the level matching section. So see you in a sec. Okay, and let's actually point out one more thing for our family matching, which is when you don't find a family match or you know there isn't one in the survey, um, uh, you can elect to skip. So if you just type in skip in your input, it will just sort of record that there isn't going to be a match, and you can go ahead and skip that job. So now we'll move on to level matching, and this is a bit easier than family matching. But essentially what we do is we pluck out information, which is happening right now, about the level. So things like words in the title that denote level, things like experience, etc. And once we have those, then we're going to feed it into an embedding model again. And we're going to ask the user to try to identify the best level. And again, since we already know the job family, this is a bit easier than matching families. So we have, again, the display of kind of the basic information you would need, the job title, some level words in that title, and then responsibilities and experience to kind of say what the person does. And then down at the bottom, we'll have the AI proposal. And then this time it's displayed as a table, and the user is going to have to select a number within that table for the best match. Again, since we already know the family, it's a much smaller list of possible matches. So in this case, we can just pick the best one in the table and input it in. And in this case, it's level 0, which was the first row, which is the most probable match. That was the correct one. Okay, so let's look at one more. So our next one is a senior director job. We know that it's a product management family from our previous section. And we can see that, yeah, it's a lot of experience and probably really is a true senior director. So we pick the first row, which since Python 0 indexes will be input number 0. Okay, so we just kind of repeat this again and again until we get through the rest of our level matches, and then we'll fast forward to get to the Excel output of the program. Okay, so now we've put in our final level selection, and the program has organized our information, looked up the correct codes, and spit it out to an Excel file for the user to review and do whatever they want with that information. So this will spit out to your current directory, and will be a pretty simple Excel file with very useful information here. Your unique identifier, your original description, your title, and then your final match ID. So this is the survey code, which is super useful that it prepares that for you. your match title and if there was a confirmation for the level and family. It will include that also. Where it doesn't have a level and family, that just means it was that early fuzzy matching section. So we just went straight to confirming the title and code. Okay, so some information about this system. This is our MVP. So we're working on a web UI that would take a lot of the work that we saw done with the user having to input directly into a console and allow them to interact with like a web page. But I should say, I'm not a software engineer, not a machine learning engineer. Jack is much smarter and more technical than I am, but we are, at heart, HR and data people. So you don't have to be a super technical expert to build something like this. The tools are right there, and especially if you use tools like ChatGPT, you can get a lot done with little previous experience. So this system was written in Python. A couple notable frameworks you used. For fine-tuning, we used MLX, which is an Apple framework to do machine learning on Apple Silicon. And then our matching script, we used a lot of frameworks besides these, but the big ones were Transformers, Torch, Flag Embedding, and sklearn. As far as the models we use, again, a big open thanks to the open source community for publishing and allowing large models to be used. So we built a lot on top of Mistral. So for our JD conversion, we fine-tuned Mistral 7b instruct. We had about 1,600 training examples that we created and trained for about 3 epochs. The family prediction program uses the base Mistral 7b instruct, so that's not fine-tuned. And then later in that program, or I guess later throughout that program, we used an embedding model for semantic similarity called BGEM3, which is also open source. So all of this can be downloaded from Hugging Face, which is an amazing resource. As far as requirements, if you wanted to like run our program or build something exactly like it and run it, you would reasonably need a large amount of memory on your computer. So nothing, crazy, but if you have a Mac with an M1 or above chip, anything over 32 gigs is probably going to be able to really easily run everything. 16 might struggle, but probably gets you through it. And 8 will probably crash when you get to the Mistral models. And then on PC, if you have a dedicated GPU that's somewhat current, that should be fine. Again, we're working on putting a UI front end on this, so it'll be much easier to work with. So stay tuned, and please reach out to either Jack or myself if you have any questions or have any other ideas for other HR applications that you want to talk through, maybe how to point AI at. So thank you.